Right.
Okay.
No.
No.
3 point.
Section 3.
No.
Yeah, we did 2B yesterday. 2A on Monday. When you were gone. It was very fun. We were graphing logarithms. So, yeah. Okay, so now we're kind of doing more like algebra stuff with logarithms. So we have the change of base formula, and then we have properties about logarithms. And I want to say we did this last year during COVID in the spring in algebra 2. So, change of base formula. So basically, if you're given like log base 2 of 5, so if we're just looking at this, I could write it as an exponential, like 2 to the x power equals 5, but we wouldn't know the exponent that actually gets us 5. We know it'd be like 2 point something, right? 2 would be 4, 3 would be 8, so it has to be between 2 and 3. So the change of base formula basically helps us figure out that decimal approximation for our exponent. So if you're given, let's just say log base b of n for a number, then this is actually equal to the log, and I'm going to say base a of n over log base a of b. So I can rewrite it with a different base, basically, if I write it as a fraction. That a value most of the times will be 10, so that way you have a common logarithm. Or it will be e for a natural logarithm. Basically, we want to write it with log base 10 or log base e because we have those buttons on our calculator that we can actually type this in and approximate. If I did log base 2 or something, that's not very helpful. So a for those part will be 10 or e. Okay. So I have log base 3 of 16. So if I rewrote this as an exponential, I'd have 3 to some power equals 16. And I can't just mentally think of what the power is going to be. So we have to use our change base formula to figure out our decimal approximation. Okay. And they say we want to evaluate with common logs. So we're going to rewrite log base 3 of 16. Common log is base 10.
Okay.
Yeah, log base 10 of 16 divided by log base 10 of 3. Okay, technically I don't need to write the 10. So if you don't write the 10, we assume it's just log base 10. So I could write it as log of 16 over log of 3. These are equivalent statements. But once you have this, we could type this in our calculator, log of 16 divided by log of 3, to get our decimal approximation. And you have your log buttons off to the left side, so like the number 7 and 4. Yeah, that's what I got. So we know the exponent for that exponential expression would be 2.5-ish. So, not too shabby. We have another one like it. So we're doing the same thing, except I want to use natural logarithms this time instead of common logarithms. So make sure, like on quizzes and tests, you actually read that, because I want to see I do both ways on the quiz. We can do it in common logarithm and a natural logarithm. So this time we have log base 5 of 22. Same thing, I could write it as an exponential, but I don't know for sure what the exponent would be. So we're going to use natural logarithms. So how could I rewrite this as a fraction? Of 5. So you have to take both numbers. Technically, I could like condense log base e. I could write it as natural log of 22. The ln represents log base e. So these are equivalent. You should write it as ln, so that way you can see the button on the calculator that you're just pressing. If you did common logarithms, you should get the same decimal approximation. I got 1.9206 if I rounded. Everybody agree with that? Okay. Alright, so we have 3 different properties. I don't know if there's names to the properties. I'm going to call this one the product property. So just remember, logarithms are basically like exponents. We evaluate the logarithm so that way I figure out the exponent that satisfies an exponential equation. So if I have log base e of n plus log base e of n, oh, am I writing that right? Yeah, okay, doesn't matter. So if you're adding the same logarithm together, so log base b, you could condense it to write it as log base b of n times n. Okay, so the reasoning behind this, so if I think of it as exponents, I have all these exponential properties. So if I start on this side, if I have b to the n power times b to the m power, to make the connection with this, how would I combine my exponents? I would add them. So basically that's the reasoning. If I'm adding the 2 logarithms together, I could find them to be multiplication. Just like it's product over here and some over here. So that's kind of why we have this property, because it is an exponential. Okay, we have another one, which is the quotient property, which is similar to my product property. So instead of adding, I'm going to be subtracting. So if I'm subtracting, then I have log base b of n divided by m. And then a reasoning for this is identical to the other one. If I have the fraction b to the n power over b to the m power, we should know the rules of exponents. If I have a quotient with the same base, I am subtracting the exponents. So it's the same thing as b to the n minus m power. That's where this property for logarithms comes from. Then we have a third one, which is kind of weird. power property. If I have log base b of n to the n power, so b is a subscript, n is the actual number, n is the exponent. So if I have some exponential inside my logarithm, I can basically move the exponent from on top and place it in front. So then it's n times log base b of just n. This one doesn't really connect to like an exponential reasoning, but logarithms are exponents, so I could just move the exponent in front and multiply by the exponent that I'm trying to find with the logarithm, which is kind of weird. We're going to work with these three properties today and tomorrow quite a bit. They should become easier to understand. Okay, so we're going to rewrite the logarithm in terms of log. Natural log of 2, natural log of 5. So we're going to use our lovely properties to rewrite the natural log of 10. So when I'm looking at it, I just need to work with the 10, and how can I use 2 and 5 to create a 10? First off. Multiply. So I could rewrite it as natural log of 2 times 5. That's the same thing as natural log of 10. So then once I have it broken like this, I can use a property to separate it into two different logarithms. So the product property says if I'm multiplying, I can separate it and write it as a sum. So the natural log of 2 plus the natural log of 5. So this is what they're asking for. We wrote natural log of 10 as a sum of natural log of 2 and 5. So that was not too bad. So doing the same thing, I have a fraction this time. I still want to write it as natural log of 5 and natural log of 2. So this fraction, I see the 5, but 32, how can I use like 5 and 2 to create 32? The net is, this one isn't showing. Okay, so there's no way to like multiply 2 and 5 to get to 32 or like divide them or anything. So we need to write it as a power. So how can I rewrite 32 as like 2 or 5 to an exponent? 2 to the 5th, yeah. So I can write it as 5 over 2 to the 5th power. Okay. So now I have a base of 5, a base of 2, which is what we need. I'm going to use my properties to expand this and rewrite it. So how do I rewrite a quotient? Yeah, so rewrite it as a difference. So we're subtracting 5 from 2 to the 5th. Okay, I can go one step further. So this piece, the natural log of 2 to the 5th, I can use the power rule to move my exponents in front of the natural log. So natural log of 5 stays the same. Natural log of 2 to the 5th becomes 5 times natural log of 2. Yeah. So 5 as the exponent pops down in front of everything, and we multiply. So this is simplified answer that we want. Okay. Find the exact value of each expression without using a calculator. Fantastic. So this reads log base 7 of the 5th root of 7. So basically we want to use the product property, the quotient property, or the power property to rewrite this so that way I get an exact value and not just type this in using change base formula. So, does anybody know how to rewrite the fifth root of 7? No, this is a lesson that nobody ever likes in algebra 2. Rewriting a radical as a fractional exponent.
Something that cancels out. Are we thinking about 7?
So I can write 7 to the first power. So I still have log base 7. And I have a base of 7, but the fifth root and the 1 are used to create the fraction. Fifth root is always in the denominator. The power is in the numerator, so it's 7 to the 1/5 power. So 7 to the 1/5. Same thing as the fifth root of 7 to the first. We have done this before, it's just been a while. Okay. So then, since I have an exponent, I can now move the exponent in front of the logarithm using our power property. So I have 1/5 times log base 7 of 7. The main reason why I want to do this is because we had a property the last couple days that simplifies log base 7 of 7. Anybody know what log base 7 of 7 is without using a calculator? Let's think about it. So using our change of base formula, if I was going that route, how would I rewrite log base 7 of 7? Change of base formula, I can use common logarithms or natural logarithms. So I can write log of 7 divided by log of 7, which have the same thing in the numerator and denominator. So basically it divides out to be 1. So log base 7 of 7 is just 1. And I'm multiplying it by this still. So my exact value without using a calculator is 1/5. Yeah. You can always check yourself with your calculator, but you should show all the work for full credit.
How many?
2? Okay. So natural log of e to the 12th power plus natural log of e to the 5th power. Any ideas where you want to start with this? How do you know it's 12 plus 5? Yeah, so natural log of e basically cancels. And you're left with the exponent 12 plus 5. It's like that log base 7 of 7. It cancels. So this is just 17. Okay. That was not too bad. So this one is log base 5 of 75 minus log base 5 of 3. So we're going to use all the properties to rewrite this thing. And ideas where to start? Yeah.
Baseball?
If I use a change of base formula, I have to use like a calculator to actually figure this out. Because it doesn't cancel like that log of 7 and log of 7 one. Quotient property. So I have a difference with the same base. So I can write this as a fraction. 1 base 5 of 75 divided by 3. What is 75 divided by 3? Okay. Okay. So now I would condense to this. Now what do I do? Okay. That's where I want to go. It's power property, but I don't have like the exponential expression of power. Can I rewrite 25 though? Yeah, so I can rewrite it as 5 to the second power. Or you can write it as 5 times 5, either one. And then you have to use the product property though. So then we know log base 505 is just 1. So it's like 1 times 2, which is 2.
Could I do assignment?
Yeah.